Hey, in this video we'll be talking about the binary number system and how you use that in C++. So binary we've discussed before in an earlier course. It is a base 2 system, which means that you have two possible values per digit. This is compared to our normal base 10 system, where you have 10 values per digit. So binary, you might have seen it before. It looks like a bunch of ones and zeros, whereas base 10 is what we're used to. This is a decimal. This is decimal, and this is binary. So when I write these out in C++, that stuff will not work. If I write the number, that's not binary. If I write something like this, this is just an integer literal. It's just a bunch of ones and zeros. It just happens to be ones and zeros. It doesn't treat it as special. It just thinks I wrote 100,101. If I want this to be treated as binary in C++, I need to use the prefix 0b, and then it treats it correctly. So that's 37 in decimal format. And I can use that just like any other integer. There we go. Looks pretty nice. C++ only recently added this prefix, so it hasn't, for a long time, it hadn't been possible to use a standard form of writing binary. There's also not really an easy way to, or an obvious way to print out values in binary. If I print out this, it's going to format it as a decimal. There is one way that's not too bad. If I include bit set, I can treat this integer as a bunch of bits, and that knows how to print it out. You have to say how many bits. Let's say it's an 8-bit, and then pass in your integer. So this can be any integer. It doesn't have to be written in this format. I'll just put I in there. There we go. And then when I run this, should show me two different formats. One is printing it out as a decimal, because that's what it evaluates to, and one is printing it out as a bit set, so that each of these zeros and ones is preserved in that sequence. So an interesting thing here, I chose 8 bits in this bit set because that's normally the size of a byte that we work on in modern hardware. So when I work with say a char data type, a char is 8 bits, and we've talked about how a char has a limited range. If you go from 0 and you add 1, and you add another one, and you add another one, let's say you're looking at this decimal value. Let me see, that's 4 bits, there's 8 bits. If I add 1 to this, it becomes 1, and you can hover over it to get it to see how it evaluates 1. If I add another 1, well, 1 is the most that a single digit can carry, so it has to carry over the 1 into the next digit. So this becomes a 0, and this becomes a 1, and that's 2. Let's add another 1, so we get 3. Add another 1, carry the 1, carry the 1, and we get 4. And so on. It counts all the way up until all of these are full. 1, 2, 3, 4, 5, 6, 7, 8. And the maximum value that I can store in 8 bits is 255. So what happens when we go too far? When we go to 255 plus 1, what happens? So let's find out. I'm going to use a special type, not just char, but I'm going to make sure that it's unsigned. Unsigned means that there's going to be no negative possible. All right, so unsigned char C equals 255, and then we'll do C++ and print that out. All right, what do you think it's going to be? What did I get? Where is it? Oh, I see. You know what? It is treating it as a char, as a character. I actually want to treat it as an integer. So let me do a little quick typecast there. Okay, that's better. So, those are from the other prints. 0. 0 is what we get. So what's happened here is we've taken this and we've added 1, so this becomes all zeros. Adding 1, the first digit is going to be a 0, carry the 1, carry the 1, carry the 1, they all become zeros. And then we get to the end where we don't have any more place to store this 1 that we're carrying over. So we just drop it. That's the best that can be done. So this is called, the situation is called overflow, and sometimes it's actually useful. You can have numbers that wrap around, going from 0 to 255 to 0 to 255 on a repeat like that. And in some cases, it causes bugs in programs. So when you're expecting a high number, but it suddenly became 0. And this happens for almost all numerical data types. Even for really big integers, if you were using a long or a long data type, you can store really big numbers, but eventually you're going to run out of space, or I should say, get to the point where in the binary representation, it's all ones. And then adding 1 more is going to flip it around. So this situation can happen pretty easily if you're not careful about it. You can usually use an if statement to check to see if you're getting toward getting too big large values. On the other hand, there's also a situation called underflow. So this works just the same. Char D. This works the same, but the other way around. So if I do D minus minus, you should expect that this should roll backwards over into 255. And so this can cause bugs too. There's one really famous bug in the Civilization games. In the very first Civ game, you build your culture and your society and your civilization, and one of your opponents might be Gandhi from India, very well known for his peace attitude, and he has an aggressiveness score of 1, which is very low, and that makes sense for what kind of person he is. But then there's a situation when you can cause your opponents to lose 2 peacefulness or 2 aggression because of a upgrade that you choose or a path that you choose in your civilization, which causes this situation to happen, this underflow, and then suddenly you have this peace-loving leader, and you do something that you think is going to make everyone even more peaceful, and suddenly Gandhi's aggression score becomes the maximum value possible, and he starts reacting crazy to everything that you do and building nukes and destroying you. So it's funny. It took them a bit to find that bug. But it made a mark on the gaming culture that grew up around that game. And in later versions of Civilization, They fixed the bug, of course, but they preserved some of that aspect of Gandhi's character, this imaginary Gandhi, to make him more aggressive or more dangerous when he does get provoked. All right. So I think that's a good overview of what we see of binary in C++, and I'll see you in the next video.